Hey guys, in this one we're looking at probability tree diagram questions. Let's go. Number 1. There are 9 counters in a bag. 7 are green, 2 are blue. Rita takes at random 2 counters from the bag. Work out the probability she takes 1 of each colour. Alright, so using trees, let's have green and blue. Alright, so for the first counter, the probability of green is 7 notes, and blue is 2 notes. Now, on her second counter, if she has taken a green, there are now 6 green out of 8 counters. And then blue is 2 8s. Or, if she took a blue on the first one, then there's 7 out of 8 green, and 1 out of 8 blue. Alright, so now we want the probability she takes 1 of each colour. So let's find the paths we are interested in. So we want either green and then blue, or blue then green. So, the probability of green then blue is 7 ninths. Now, when we go along the branches, we multiply. So it's 7 ninths times 2 eighths, which is 1 quarter. So we have 7 ninths times 1 quarter, so that's 7 over 36. Or blue and then green that's 2 ninths times 7 eighths. So that's 14 over 72. Which simplifies to 736. Alright, so we have the probabilities of the 2 events we're interested in. Now we just add them together. So the probability of 1 each is 1436, which is 7/18. Number 2, there are 30 students in Mr. Lear's class. 16 of them are boys. 2 students are chosen at random, and he draws this probability tree diagram. Part A wants us to find one thing wrong with the diagram. So, the first tree is right. 14 boys, 16 girls, out of 30 good times. Now once 1 has been chosen, there's only 29 students to then choose from. So in the second trees, the bottoms of the fractions should now be 29. Part B, Owen and Wasim play for the school football team. The probability Owen scores in the next match is 0.4, and for Wasim it's 0.25. Mr. Slater says the probability they both score in the next match is 0.4 and 0.25. Is Mr. Slater right? Well, the answer is no. Now, what he has worked out is the probability that one of them will score in the next match. So, to work out the probability they both score, we would need to do 0.4 times 0.25. And that would give us 0.1. Number 3, there are 12 counters in a bag. There are equal numbers of red, blue and yellow, so 4 of each. There are no other counters in the bag. 3 counters are taken at random. Work out the probability we get 3 red counters. Alright, so for this we could use a tree, but sometimes it's easier not to. So we know the probability of getting a red on the first try is 4/12. So I'm going to call this the probability of red, red, red. So it's 4/12 times. Now if we've taken 1 red, there's now 3 left out of 11 counters. Now if we've taken 2 reds, there's now 2 left out of 10 counters. So it's 2/10 for the third one. So, going across the top, 4 times 3 times 2 is 24. And on the bottom, 12 times 11 is 132, times by 10 is 1,320. Now, we could simplify that, but we're not asked to, so don't bother. Okay then, part B, the 3 counters are put back into the bag, and some more counters are added. There's still an equal number of red, blue and yellow, with no other colour counters in the bag. Is it now more likely, equally likely, or less likely to get 3 reds? Alright, so let's think about this. If we just put one more red counter in, we're putting in 2 more that are not red. So there's going to be more counters overall and more new counters that are not red. So it's less likely now and we could say more counters that are not red are being put into the bag than red counters. Stop. Alan has 2 spinners, spinner A and spinner B. Each spinner can only land on red or white. The probability A lands on red is 0.25 and 0.6 for spinner B. So the tree diagram has the probabilities on that. Now we're told Alan spins the spinners a number of times. The number of times both spinners land on red is 24. We want to work out an estimate for the number of times both will land on white. Alright, so what we're going to do is work out the probability of red. Then we're going to think about that as a percentage. From that, we can work out the total number of times he has spun the spinners. Then work out the probability of white, and then find the number of times for white. Alright, so the probability of red is 0.25 times 0.6. Now that is 0.15. So that would tell us only as an estimate, because probability is not a rule. So as an estimate, that tells us 15% of the spins have resulted in both landing on red. So we could say 15% of the total spins is 24, because we landed on red 24 times. So from that we can work out what 5% of the total spins would be. So dividing by 3 we get 8. Now we can work out 100%. By multiplying by 20. So we get 160. Alright, so that's our estimate for the total number of times he span the spinners. Now we're going to work out the probability of white. So that is going to be 0.75 times 0.4. Now that is 0.3. So, to work out the estimated number of times he got white, we now do 0.3 times 160. And that gives us 48. Final question. A fair spinner has 5 equal sections, numbered 1 to 5. A fair 6-sided dice has 5 red and 1 green face. The spinner is spun. If the spinner lands on an even number, the dice is thrown. Part A wants us to complete the tree diagram. Alright, so the dice is only thrown if the spinner lands on an even number. Alright, so on the spinner, the even numbers are 2 and 4. So that's 2 out of 5. And the odd is 1, 3 and 5. So that's 3 out of 5. Alright. Now the dice can land on red or green. 5 faces are red, so that's 5, 6. And then a 1/6 for green. Okay, then part B wants the probability of an even number and then green. So that's 2/5 times 1/6. Now that is 2/30 or 1/15. Alright guys, that's the end of this one. Really hope it's helped. So I have another set of questions on tree diagrams. That's coming up next. Hope to see you there. Take it easy. Take care.